I think of Bitcoin really as three things. It is a store of value like gold. It is a rail on which value can move around the world, and it's a ledger.
You can think of it like a type of database that has certain properties. All the data is cryptographically signed, all the data is linked, the data is typically replicated across many different nodes.
It's the most interesting use case of cryptography we've seen in the last 2 decades.
So a consensus mechanism in a blockchain is basically the way that that you create a trusted network using untrusted network participants.
Fundamentally, a blockchain and the associated machinery of a network like Bitcoin allows us to transfer value and transfer electronic money without copying it and without relying on an intermediary that's the one sort of saying, okay, I'll subtract 5 from here and add 5 to here.
Many of us saw the rise of peer-to-peer networking 10 to 15 years ago. And when you use products like Skype, you implicitly get free calls and you don't realize that your resources are actually being used by other people. In the new blockchain world, we have to have a way to incentivize people to push their resources into the servers and be part of the network. And that's what's so exciting about tokens, offering tokens and economic incentives and markets to encourage behavior.
Both public and private blockchains, you can think of them like giant virtual safe deposit box walls. Like when you go into the bank, there's a bunch of accounts and each of those boxes has a key and you have to take your key and unlock the box to get your funds out.
Ultimately, all digital assets and digital currencies, the ownership is changed hands by whoever has the private key. And so it's a password.
The so-called Byzantine generalist problem of coming to consensus in the adversarial environment was something that did not have any practical solution prior to Satoshi Nakamoto's paper.
Conceptually, a public blockchain is one in which there's no bank around that safe deposit box, that you can access that system directly. You have a key and you can just go up to this wall with no permissioning required.
If you're just trying to use it as a database or something, that's obviously not the best use case. You should just use a normal database.
I think an early indicator of a successful technology wave is where the developers are going early on. When the Satoshi paper came out, we saw a lot of smart folks stop what they were doing and rush to go learn more about this new ecosystem. I think we've seen some of those same developers migrate to new projects, let's say from Bitcoin to Ethereum, as they're inventing new tokens on top of that platform.
As a technology platform, Ethereum is clearly better. It's meant to be developed for, you don't have to code in like this assembly-like language of Bitcoin opcodes and script. It's something that wants to change and be flexible. Whereas digital gold really doesn't want to change and doesn't want to be flexible.
One of the reasons why blockchain is not scalable is because it's a replicated database. So everyone has to maintain a copy of the ledger and everyone has to update the state at the same time. That's like really, really computationally heavy.
There's no reason you should be using Bitcoin to buy a cup of coffee and have it validated by 100,000 nodes around the world to buy a $5 coffee from Starbucks.
In the case of Bitcoin, a lot of the effort to scale the network and to innovate is at the sort of what's called level 2 or layer 2 networks and technologies like the Lightning Network that allow you to process transactions essentially off the chain, but still in a relatively trustless manner by essentially pre-funding accounts and locking those funds into channels, and then settling out only periodically to the Bitcoin network, which allows the Bitcoin network to form more of a settlement layer and then a payment layer that sits on top.
Fundamentally, what do you need to publish to a blockchain? To a visible, always on, always verified repository of information and audit? And the answer is the results, not necessarily the interim.
Proof of work itself, and usually whenever people talk about energy costs, they're referring to proof of work, that computers are doing these mindless calculations and just throwing them away. And that's energy cost.
There's various ways to fix that. One is like, let's distribute this load across many, many servers, just like traditional databases. Databases, when you distribute them, you don't keep a copy of them in each location. Instead, you distribute various shards into different locations. So Ethereum has a sharding solution that's in line.
Where will most of the computations would happen? Where would most of the data will be stored? It's not going to be on the blockchain. I think we'll have to take data off the blockchain, most of the heavy processing off the blockchain.
So sort of scalability, I call it, is definitely the biggest challenge right now. So Ethereum is maxed out, does about 1.2 million transactions a day, and it's pretty much hit the maximum that it can support right now. That's the bad news. The good news is there's a whole bunch of projects by the Ethereum Foundation competing so-called blockchain 3.0 projects that compete with Ethereum.
Bitcoin is extremely useful as a store of value, but also as a very secure base layer for building other things on top of it. There needs to exist a very secure proof of work blockchain, and right now Bitcoin by default is that system.
The exciting thing about blockchains is nobody really knows where all this is going to go. We don't know if proof of work or proof of stake is going to be the right consensus mechanism, but all this energy and all this innovation is going into this area right now.